So good morning, all of you. So good to meet you again for the next session of the morning. So I'm happy to welcome Pranav Bharadwaj. So he is from Tosh Innovations. So this talk is going to be on the topic Ethereum fundamentals. So this is just a brief profile of Pranav Bharadwaj. So Pranav Bharadwaj is a certified blockchain developer and a Red Hat certified engineer. So he has imparted multiple training and hosted workshop for expanding the knowledge base of blockchain and focusing on how the same can be leveraged in the industry. So he has 8 years of experience in web application building and telecom industry, and more than 4 years experience in blockchain development, having developed applications for insurance, healthcare, and logistics domain. Okay, so it's going to be a very interesting session on Ethereum overviews. So I would ask Pranav to take over. Yeah. Thank you, Pranav. Yeah, please take over.
Thank you, Shakti sir, for this introduction. Let me just quickly introduce myself, though Mr. Shakti has already done that and he has explained most about it. I'm going to take the Ethereum overview session today for all of you, and what we'll be covering is the Ethereum basics. What is Ethereum all about? How Ethereum changed the world and how is it still changing? And we'll have a quick smart contract development session that how exactly is the code deployed onto the Ethereum blockchain? How do we test smart contracts? What are smart contracts and everything? So if I may ask you before starting off with Ethereum, do we have any questions around the fundamental concepts of blockchain, or is it clear? Because I want to make that very clear before proceeding. If there is some fundamental concept of blockchain is missing, then Ethereum might just straight away starting off from Ethereum might not be that true. So any questions or comments on blockchain that you want to ask first and before we get started? Any fundamental questions? Blockchain is not clear, or you have something related to Bitcoin? Don't be in trouble, folks, if I start asking you questions. Ask whatever you want, just utilize this time to the best possible extent so that you are all taking away good learning from here. Okay, so I don't see any questions in the Q&A, and I believe we are all in good shape and have understanding of what blockchain is all about. Blockchain being a distributed database. The way all of us have initially worked with BitTorrent, the files are distributed in space. Blockchain was something built very similar on those lines, but with more and more security, that exactly the same files are replicated across multiple computers or nodes. Now, so what is Ethereum? The world came to know about the word blockchain from Bitcoin, right? If Bitcoin wouldn't have come in, this technology would still have been unknown. But Ethereum made blockchain more powerful. Bitcoin was built only as a payment system, only to send payments. But Ethereum, when it came in 2015, that's when Ethereum got the computing power to be distributed and gotten the ability to build applications on top of blockchain. Right now, we are building the traditional stack says that we build applications on the internet. We host them on some servers. How can the applications be hosted in a decentralized fashion? How can the applications be made more secure? How can the computing energy be distributed through the network? How can we build a trustless environment? Now, when I use the term trustless, what do I mean by trustless? Instead of trusting the people, instead of relying on the people, you trust the network. You trust the network of nodes. You trust the cryptographic algorithms that are running out there in the network. So, Ethereum is a futuristic open source blockchain network for building decentralized applications, and in short, we call them as DApps. Powered by smart contracts and combined with digital native currency Ether. On Ethereum, your code can be written to monitor digital value transfer depending on programmable conditions. The way we have our legal contracts, right? And those are business rules. If two organizations are working together, they do sign some agreement, they do have some business rules which are written into a legal contract, and the contract is submitted with both the parties. Now, those legal contracts are simply paper contracts, right? If someone has to do any malpractice with the network, with their business, they can do that, and they will think, hey, some disputes are going to arise, and I can take care of them at a later point of time. And that dispute handling currently keeps on happening. But when you have smart contracts out there and your business rules are written inside the smart contract, that's when, even if you try to inject a faulty transaction, that transaction doesn't take place. That transaction is rejected by the smart contract and it never happens. Hence, there is no point of any disputes getting arised because of the legal contracts. The legal contracts that we write are now being written in the form of a code. That's where Ethereum became more powerful. So Ethereum was designed to build on the primary role of Bitcoin as a centralized peer-to-peer currency by introducing a network able to implement smart contracts and more complex systems such as decentralized applications and decentralized autonomous organizations. Think of an organization where you don't have any of the presidents, you don't have the CEOs, and all the employees are just working and they're part of a decentralized network. Now the rules of the company are being governed by the smart contract. That's what decentralized autonomous organizations are. The organizations which are running without any leading authority, and they're being governed by a code. That's just a concept right now. It will take some time for this concept to come to reality, but yes, a lot of work is happening around the space for making this concept as a reality. Ethereum, being a blockchain, it possesses, being a public blockchain, it possesses a cryptocurrency called Ether, which is denoted by ETH. The network actually started on 30th of July 2015, and right now the one Ether values $590. That's because of the heavy trading in the crypto industry. One Ether is $590. The total market cap of Ethereum is somewhere around $40.6 billion in the industry, and the average block mining time is 15 seconds. It says 13 seconds, it might go up to 20 seconds depending on the network latencies, but the average time comes to around always 13 to 15 seconds. Talking about the market segment, we have a digital currency, that's Ether. You can do investments out there. You can use Ethers to buy products on various websites. Of course, not in India because it's not properly legal out here, but in many countries, you can buy property, you can buy pizzas, with Bitcoin and Ethers. I read this news last week that Venezuela, the Pizza Hut in Venezuela is now accepting payments in Bitcoins. So the adoption has just started, and it would be there in some, in the next few years, I would say. Bitcoin versus Ethereum. Bitcoin denoted by BTC, while Ethereum is denoted by ETH. The founder of the Bitcoin is an unknown person. We don't know who that person is. It's just believed that the name of the person was Satoshi Nakamoto. Then we have Vitalik Buterin and team who founded Ethereum. Satoshi is the smallest unit of Bitcoin, whereas V is the smallest unit of Ethers. The way Paisa is to rupee, cents is to dollar, cents is to euro. In a similar way, Satoshi is to BTC and V is to Ethers. We have total 18 zeros out here, right? In Paisa, we have 2 zeros, right? In cents, we have 2 zeros. Maximum supply, 21 million. There can be only 21 million Bitcoins in this world, whereas there is no fixed supply on the Ethereum network. Block reward of Bitcoin right now is 6.525 BTCs. What is that block reward? So that every time a miner is basically mining a block, they have mined a block, they need to be rewarded for mining a block. And the reward is 6.25 BTCs. That with today's value of Bitcoin, it comes to around $120,000 for mining one single block. The block reward in Ethers is 2 Ethers plus the transaction fee, which comes out of all the transactions in the block. Talking about the miner fee is being collected by the miners, and the transaction fee in the form of gas is connected in the Ethereum world. In the Ethereum world, we say that the transaction fee was gas. Gas is nothing but the fuel due to which the Ethereum network is up and running. So for every transaction you do on Ethereum, for not only a financial transaction, not only a payments transaction, you have to pay gas, which is your transaction fee. Talking about the consensus algorithm, Bitcoin uses proof of work, where the nodes have to solve a mathematical puzzle, and they need to be and they are a part of the race. So whosoever solves the puzzle first, that person is rewarded, or that node is in fact rewarded with a block reward of 6.25 BTCs. Ethereum was working on proof of work till now. On 1st of December, Ethereum 2.0 has been launched, where Ethereum has moved to proof of stake, which is a new consensus algorithm. I'll explain that to you in detail. Just bear with me for some time. The purpose of Bitcoin, to become a global decentralized payment system, whereas for Ethereum, it is to become not only a decentralized payment system, but also to power decentralized applications on top of blockchain. Right? On top of this immutable ledger. Proof of work versus proof of stake. So in proof of work, your mining capacity depends on the computational power, whereas in proof of stake, your validating capacity depends on the stake in the network. It's very similar to buying shares in a company. In proof of work, who solves the mathematical puzzle first? Who figures out the nonce value first? That person actually wins the race. And in that case, people are actually staking their resources. People are spending millions in in buying those heavy GPU graphic processing units for making the calculations run at speed of 1 million, 2 million transactions per second. That's how much hashing those computers need to do. And that's the reason, because of the block reward, they are spending so much money for keeping the network up and running. What happens in proof of stake? You don't have to run any heavyweight calculations. And this was one of the reasons why Ethereum moved away from proof of work. The sole reason being, proof of work is not an environment-friendly operation. Right now, Bitcoin mining is consuming more energy than entire Portugal. So such compute-intensive algorithms, such compute-intensive resources cannot run the environment, and that's why moving away from proof of work to proof of stake was a major upgrade for Ethereum. In proof of stake, a person who has got more number of ethers will be given more chances to mine a block. The concept comes from a fact that you have a person, okay, not you, I would say a person who has got more stake in a firm, he is less likely to do any malpractice with the firm because he has got his own money at stake. Right? That person is very less likely to do any malpractice because that person has got his money at stake. The same concept comes to proof of stake. If you want to be a miner, you deposit ethers and you put them at stake. If you are caught doing any malpractice with the network, the money that you have put at stake is going to be taken away. So you lock your amount. Whosoever locks more amount is going to get more chances of mining a block. Miners in Bitcoin, miners receive blocks rewards to solve a cryptographic puzzle. They used to receive in ethers also till date, till the time Ethereum is working on proof of work. And validators do not receive a block reward. Instead, they collect the transaction fee as a reward. Hackers would need to have a computer powerful than 51% of the network to add a malicious block, leading to a 51% attack. 51% attack refers to a point that when you have brought in a computer, a machine, which is more powerful than 51% of the network, that's where the consensus algorithms might fail. Because you have got the consensus on your side. If there are 100 nodes in the network, you have got the power of 501. In Ethereum, hacker, in order to do a malicious transaction, they would need to own 51% of all the cryptocurrency on the network, which is practically impossible. One ether right now is around $600. So 51% of all the ethers in the network is something that is not possible, and therefore making 51% attacks impossible. So this is a big migration from proof of work to proof of stake. Right? Ethereum virtual machine. I believe some of you would have worked with Java or any other programming languages, and always we need to have a compiler. In the Ethereum world, we write down the smart contracts in a language called Solidity. Now, Solidity is an Ethereum specific language, which is very similar to JavaScript, and the code is actually compiled in the Ethereum virtual machine. When you start working with Ethereum, either you work with Go Ethereum, which is Git client, or you work with EVM, or you work with Ganache. These are the different tools to test out your smart contract. Without EVM, you cannot compile the smart contract. Every node contains an EVM. The way you have JVM, Java Virtual Machine, similarly you have EVM in order to compile the code. The EVM is an efficient virtualized computing stack embedded within every full Ethereum node, which is responsible for executing bytecode contract. Contracts are usually written in high-level languages, such as Solidity, and then compiled into the EVM bytecode. Each node in the Ethereum network executes an instance of EVM that allows them to agree on the same instruction. The EVM is Turing complete, which means they can execute every logical step of the computational process. The coding language for Bitcoin is Turing incomplete. If I have to explain this to you in layman's terms, it refers to looping. You can write loops, whereas in Bitcoin, you cannot write loops. It gives you the power to write loops. EVM is successfully implemented in different programming languages like C++, Java, JavaScript, Python, Ruby, and there are a few others. Dr. Gavin Wood developed the EVM in 2014 and outlined the theoretical version in the original Ethereum yellow paper, which is similar to the white paper. Now, let me, while we discussed about bytecode, we discussed about, all right, I believe I'm not sharing that screen. I need to stop sharing for a second. Allow me a second. Okay. So on etherscan.io, is my screen visible? Back again?
Yes, yes, it is visible.
All right. Thank you. So on etherscan.io, we can see the live public Ethereum blockchain, which is running. These are the latest blocks that have been formed. And in these blocks, you can actually look down to what are those transactions that have actually gone into this block. So there are multiple transactions that actually get into a block. Within those 15 seconds, whatever transactions are happening, they are getting into a block. Now, when we say a smart contract is written on and it is compiled in the EVM bytecode. For example, I'm going to open this smart contract. Just for everyone's reference, the way to identify that it is a smart contract transaction is that you look for this contract. Okay, so this means it's a smart contract transaction, and wherever you don't see any contract, that means it is a plain financial transaction. Right? So I open the smart contract. I can go to contract because this is public blockchain. It's an open ledger and it's open to everyone. And here is the Solidity smart contract. Now, when you compile the smart contract, it returns you ABI and it returns you the bytecode. This is your ABI. ABI stands for Application Binary Interface. All your functions sitting in your smart contract are converted to ABI so that the EVM can read it. And your code to be readable gets created into this bytecode, which you see out here. You can decompile this bytecode, decompile. There you go. You have the contract out there. So when you compile it using EVM, it gets converted into this form, right? Okay. Now, what is Ether? Ether is the alternative to the payment issue, a digital asset bearer such as a bond or a security. It's just like any other currency. It's just like any other cryptocurrency. It's a digital asset. Just like cash, it does not require the processing or approval of transactions by third parties. This can be used as fuel for the applications on the open Ethereum network, according to Ethereum. I'll show you that how this fuel is actually being used and how we calculate the pricing of every transaction on the network. This gives the node the opportunity to verify blocks on the Ethereum network containing smart contract code. Each time a block is validated, it generates 2 ethers and assigns them to the successful node. That is nothing but the block reward. Maximum ether supply isn't capped like the Bitcoin supply at 21 million Bitcoins. V versus Ether, we know that V has got 18 zeros and it's the smallest unit of Ether. So one Ether has got 18 zeros V. Then we have milli Ether, we have micro Ether, we have giga Ether, which is 1 billionth of the Ether. Then we have MV, KV, and V. These are the small units of Ether. Generally, we define the gas price in GV, which is gigawatt. V is named after VDAI, an activist in cryptography, considered to promote popular use of powerful cryptography and privacy-oriented technology. Ethereum mining. Ethereum mining is computationally rigorous work that requires a substantial amount of time and computing power. It uses proof of work. It runs exactly the same way. Don't ever try to mine ethers connecting to the main Ethereum network on your laptop, because your computer is going to fume even if you try to connect your laptop to the main Ethereum network and start the mining operation. You can, of course, build a private Ethereum blockchain on your laptops, but you cannot connect your laptop to the main Ethereum network and start the mining operation, because these mining operations require heavy computational power and which cannot be delivered by our laptops. There are 3 ways Ethereum can be mined. One is the pool mining, one is the solo mining, and one is the cloud mining. If we are 5 people in a group and we decide that, of course, I'm not that rich that I can go in and invest and buy a complete GPU. I don't afford to spend $1 million on a computer. Those 5 folks who can, in fact, afford and support others in giving the computational power, they are going to mine together. So we know that, this is my assumption, that as you had the Bitcoin session yesterday, you are aware of what the nonce value is and the mathematical puzzle. Now, these 5 folks are going to divide the nonce value. You run a computer ranging from 0 to 100,000. The other person is going to run from 100,001 to 200,000 and so on. Whosoever wins the race, whosoever is able to mine a block, they are going to divide the block reward as well. So you are sharing your computational power, but in the end, you are dividing the block reward as well. Right? The simplest and the cheapest way to get started is by pool mining. All the people who mine in a single pool agree to the term that they're going to share the rewards with others if one of them finds the correct answer to the puzzle. That's pool mining. Mining alone, which is also termed as solo mining. If you can afford to mine alone and you can invest 50 lakh rupees in buying a computer, which is powerful enough, you can run the mining operation on your own. No one is stopping you. And the entire block reward will be enjoyed by you. Cloud mining. If you use cloud mining, you pay someone else to mine for you. It's basically that someone is mining and I'll be getting the partial output. That hey, you mine and I'm just giving you I'll be giving you this much share, and it's a kind of pool mining, but we refer to it as cloud mining. This way works if you hire out other people's mining time and in exchange they give you all the rewards, they will mine. All right. Smart contracts. A self-executing piece of code on top of blockchain. Blockchain is our decentralized database technology. It's no rocket science. It's simply a database. If I have to build a traditional stack right now, when we build web applications, what are those three layers that we have? We have the front end, which is built in AngularJS, Angular, React, HTML, CSS, right? Then you have the API management layer, where you build REST APIs in Java Spring Boot. You build in Node.js or any other framework. And out here, you have the blockchain. In the traditional web stack, you have a database here. For example, Oracle, SQL, NoSQL, etc. What blockchain has done, that it has removed the database from the third layer, and we have added cryptographically secure nodes in that position. So over here, instead of running a database, we have blockchain nodes, I would say. When two organizations are doing business together, see how secure this would be. So there is one firm which is having two offices, one in Jaipur and one in Delhi, right? And this is your API layer, and this is your blockchain node. How is blockchain different? The way to imagine this is that you have, this is your Delhi office and this is your Jaipur office. Your nodes are connected like this. A person is actually sitting out here. They are So this person is actually operating on the system, on the web browser, and doing some operation. The call from the web browser comes here. From here, it comes to the blockchain node. When this person initiates a transaction, then these two nodes talk to each other. If both these nodes achieve consensus that the transaction is legitimate, that's when the transaction is stored on the blockchain, else the transaction is going to be rejected and the person will see an error on the web screen that this is some error and this transaction is not legitimate. If this would have been a traditional database, your transaction would have simply gone and got stored in the database, but it wouldn't have looked for any consensus from any other node. If someone is doing manipulation in a contract and going against the contract, he cannot do that operation because that person needs the approval from the other organization. Right? That's where the power of smart contracts kick in. Your smart contracts are located on blockchain. It depends from blockchain to blockchain. On Hyperledger, they are installed on the peer nodes, whereas on Ethereum, they are executed on top of the Ethereum network as a transaction. So imagine it that this node has got us access to the smart contract. This node has got us access to the smart contract. If in your smart contract, the condition is written A equals A plus 1. The person in Delhi, they tried to change the value of A. Or they didn't try to change the value of A, they tried to change the contract. Apologies for that. Now, when you send in a transaction, Jaipur's node will say, someone has given a transaction of A is equal to 0. So Jaipur's node will say that I have read the value of A as 0, but what I'm going to write to the ledger, to the blockchain, is A equal to 1 after executing the smart contract. But Delhi's nodes, someone tried to manipulate the legal contract, the smart contract, and they changed the contract to A is equal to A plus 2. The outputs generated by both the nodes are not going to match. That's how validation happens. This is at a very high level right now. And that's how actually nodes have to achieve consensus. The way nodes achieve consensus in the proof of work puzzle by validating the nonce value, and everyone should achieve the same output by validating the nonce value. The same thing happens with the smart contract. Every transaction should be permitted. Right. So what we are replacing right now are the legal contracts. A smart contract is a self-executing contract whereby the terms of the settlement between the buyer and the seller are translated directly into the code. The code and the contracts comprises of or operate through a network of distributed, decentralized blockchains, and the code governs the execution of the contract. As the first step, a contract between the parties is written as code and published into the blockchain. Individuals involved are anonymous, but the contract is visible in the public ledger. A triggering event like an expiration date or a strike price, something happened and you hit the smart contract. And the contract gets executed itself according to the coded terms. Regulators can use blockchain to understand the activity in the market while maintaining the privacy of individual actors' positions. So these are the automated executors of the code. I'm just going to give you one example that how smart contracts make it powerful right after this slide, because it's very important to understand the concept that how we build decentralized applications. So transaction, gas, and fee. Transactions are signed messages produced, distributed, and registered on the Ethereum blockchain by an externally owned account. Right now, all of us are in this forum. Let's assume that we have a blockchain network within us. Now, transaction, many folks assume that transaction can only be a financial transaction. If I send someone money, that will be a transaction. No, that's not the case. Anything that you store in the ledger is a transaction. Doesn't matter it involves money or not. Anything that you store in the blockchain is a transaction. Be it data, be it a financial transaction. At the end of the day, when you do a financial transaction, that is also stored as a data. That is also stored as a byte array. That is that the payload still comes in JSON. Right? So whatever you store on the blockchain is a transaction. If a person named John has bought a vehicle, the make of the vehicle is Honda, and for example, let me quickly build some payload. Okay, so name is John, then John has bought a vehicle. The registration ID of the vehicle is 1234. Make is Honda. Okay, and car is City. Now this is the payload data that comes in, and you want to save this to blockchain. When you are going to save this to blockchain, this is also a transaction. Any interaction, any time you want to save something to the ledger is a transaction. Don't confuse yourself that only sending money or sharing money is a transaction. No, that's not the case. Right? So gas is the method used to calculate the fee needed for a particular computation. For every transaction, you need to pay some gas. Ethereum has got its inbuilt methods and it has allocated the gas price for every method. Gas price is the amount of ether that the customer is willing to pay on each gas unit. And transaction fee is finally gas price into the gas used. So if your gas price is 20 gigaway and the gas used is let's say 5,000 V. So you multiply it and then you convert it into the value of ethers. That's the value of your transaction in monetary terms. Whatever it is, it would come $0.5, $1, whatever it would be, based on the Ethereum price that day. This is one of the risks in the Ethereum world when you actually build applications on the public blockchain, because you don't know that what happens to the ether's value if the gas price goes up. And this is a functional risk while building applications with ethers. In the permissioned blockchain platforms, you don't have this risk. Even if you take the Ethereum code and you build an Ethereum, network, a private network of your own, where you are going to play with dummy ethers, there is no risk involved. But when you deploy something on the public Ethereum blockchain, this is one of the risks involved, that the gas price might go high. Because in order to do transactions on the public Ethereum blockchain, you have to pay with the real ethers, and real ethers means real dollars. Right? One quick example to understand smart contracts and their baseline. So we have an insurance firm. Okay, this is an insurance company. All of us know that how difficult it is to get money from the insurance firms, right? They'll make you go around in loops. I don't know for how many days, for how many mails, how many documents they're going to ask you, and then give you the money. And else you might just be chasing them for weeks, for months to give you the money. Now, there is a farmer who has bought insurance from this insurance firm. This is the farmer who has bought insurance from this insurance firm. The insurance was about drought. The farmer says that if my crops got spoiled due to drought, I'm going to file a claim. Now the crops got spoiled. There was no rain in the region from, let's say, 1st October till 30th October. Now farmer has raised a claim to the insurance firm that I want my money because there was no rain in my area. What happens in the traditional world? The insurance firm is first going to register the claim. Then that insurance firm is going to send some representative to the village where the farmer is located and to check if there was no rain in that area due to which crops got spoiled. Now, if that's the truth, then that person is going to come back and he'll say, yes, there was no rain in that area and this is a legitimate claim, this is a valid claim. And this entire process of a person going there, coming back, filing the reports, creating the task is going to take weeks, at least 4 to 6 weeks of time. But if this insurance companies are operating on smart contracts, let's assume that this insurance firm has got this node. Now, this is the smart contract. Okay. This is your smart contract. The moment farmer raises a claim to this insurance firm, the smart contract is going to call, let's assume, a weather API, a Google API. Okay, Google weather API. From the smart contract, a call will go to the Google API. Google API is going to, and you'll feed in that I want the weather for this particular latitude and longitude from 1st October till 30th October. The Google weather report is going to return the smart contract, the values of that region, and the smart contract will get the information if there was rain in that area or not. This is a very high level example that I'm sharing with you just to explain that how smart contracts can actually come to use. So smart contract has got the information. The smart contract, if the claim is valid, the smart contract is going to trigger the payment then and there. The moment the claim arrives, it gets vetted from the Google Weather API and you receive the information. The claim is settled. And the claim is settled on blockchain. a person can actually go to this public ledger node and they can view that what transaction actually came in, what was the value, because no, this is an immutable ledger. No one can actually go into the database and make any changes, right? So that's smart contract. All right. Any quick questions, thoughts, comments? Let me take a look at the Q&A pane if I have anything. I don't see any questions out here. Any questions? Let me just take a pause and see if there's anything. All right. So Ethereum clients, Git, which stands for Go Ethereum. The entire Ethereum code is being built in Go Ethereum, and the language is Golang, which is a Google's developed language. This language is now coming up to pace at a very quickly in the market, and it's pretty fast. If you understand C, if you understand C++, you'll understand Golang with these. Git stands for Go Ethereum. It is written in Google's Go language, which comes in 3 original implementations of Ethereum protocol, along with C++ and Python. Git is a CLI client to run the Ethereum node, and it is the most popular CLI client for the Ethereum network. Git client is available on various platforms on Windows, Mac OS, Linux. I would say if you work with Windows, then you're going to face many challenges. So the best thing is to install a virtual box on top of your Windows machine and clone an Ubuntu ISO image out there so that you have a Linux environment to do this development. Running a node helps users to perform transactions on the Ethereum network and communicate with the smart contracts. The Ethereum community builds and maintains Go Ethereum, which is the Git client. It is open source, which ensures that through its GitHub, anyone can contribute to Git. Parity, which is another Ethereum client. Parity states that it is the fastest and the lightest Ethereum client among all. But if I talk about the ground level development, then most of the development that we do is using Git because Git is good performance wise. Or now, in fact, using Git is I mean, if you want to build and test your smart contracts, we use Ganesh, which I'll be demoing you in the next session. It is written in Rust language, which provides enhanced reliability, performance, and clarity of code. Parity Ethereum is again an open source software application, allowing any person to run a node on the public Ethereum network and some other blockchain network using the Ethereum protocol. It is an alternative to the Git Ethereum client. It provides you multi-signature wallet support. That's one benefit of Parity over Git. When you talk about multi-signature, we are talking about signing the transaction with 2 private keys. That's what multi-signature is all about. Although both Git and Parity, Ethereum is well-maintained and active projects, a reputation for consistency and versatility has been gained for Parity client. This also provides some useful capabilities for blockchains consortium and the enterprise applications. So these are the 2 clients. All right. ERC20, which is a token standard to be built on top of Ethereum blockchain. That is ERC20. There are multiple standards right now, but ERC20 was the first one and one of the most common and the most famous standards followed while building cryptocurrency on top of Ethereum. So ERC stands for Ethereum Request for Comment, and 20 is the identifier for the protocol. This is a common standard on Ethereum blockchain for creating tokens. The token specification describes a series of rules that extends to all ERC20 tokens, allowing them to communicate with each other seamlessly. Whenever you want to build a token on top of Ethereum blockchain, you need to follow the standards. If you don't want to follow the standards, you can still build a coin using the smart contract. All of this is actually coded inside the Genesis block. Your blockchain starts from Genesis block, and you need to define the total supply of these tokens the way Bitcoin has defined 21 million. The transfer, who is going to approve the initial phase, the allowance, the balance of, and the transfer from. You need to define the token name, the symbol of the token, and the decimal, which is up to 18 digits. The way we know that one Ether has got 18 zeros V, in a similar way, you need to define the decimal places up to 18. You can build your token on your private Ethereum chain. You can define that, okay, this is your token, right? You can define 100 billion. That can be any number. It's completely under your control. Most of the tokens that you see right now on crypto exchanges, those tokens are built on ERC20, and they all have their supply. How did those tokens manage to come to the market? Why are people buying them? The easiest way or the simplest way to create a token is to publish a white paper, and due to which a lot of ICOs were in fact fake. I believe the number comes to around 93% of the ICOs were fake in 2019, because making money for the people became really easy, and some people really played with the credibility of the developers. Now, ICO stands for initial coin offering. With Ethereum, with a very minimal infrastructure, you can easily build an Ethereum token. And when you build an Ethereum token, you create a very fancy website. On that website, you write, this is my idea, and this is what my digital asset is all about. You publish a white paper. You publish a white paper that this is the service that I'm going to offer. Right now, my tokens are very cheap. Like in $1, you can get 100 coins, because at the end of the day, you don't have any control. You have built a billion tokens. People start buying your tokens, trusting your white paper that you are going to that you have published, and you are going to build some service in the future. And if that service has got an excellent scope, then people will start believing and they will start buying your tokens. That's where the fiat money starts coming in. Imagine the world that how many tokens people have actually sold like this. Once the initial funding, initial sale of the tokens has been done, who knows, the other person shuts down the website and you are just looking for that, hey, I bought these tokens. What will you do with tokens? But if those tokens are valid, they are credible, they come to crypto exchanges, and that's where the trading starts, just like share trading. Right? So the price is totally dependent on the value and also on the news, I would say. If today Mr. Warren Buffett comes in and says that Ethereum or Bitcoin is a Ponzi scheme, reading the news, people who possess Bitcoins, they are going to sell it all. They will say, hey, and news affects the pricing. The price of that crypto asset is going to come down drastically, right? These are the different tokens. There are many, more than 100, 200, 300 tokens listed on crypto exchanges. In India, the famous crypto exchanges are ZepPay, WazirX. These are some of the famous crypto exchanges. Be cautious while you're investing in cryptocurrencies because we have seen a very turbulent ride of crypto in India till now. At times, Supreme Court allows the cryptocurrencies, and at times they withdraw. And these exchanges need to shut down their operations as soon they get these guidelines. All right. Talking about Ethereum test networks. Before starting, let me check if there are any questions. Okay, no questions. So, test networks overview. There are multiple ways, multiple frameworks developed for Ethereum to test them out, and these are just a few. And I'll be discussing with you the development environments, and will demonstrate you the complete suite that how it is being used to test the smart contracts. The Ethereum test network is an Ethereum replica. Ethereum says the way transactions happen on my public network, they should happen exactly the same way on a private network as well. If you have to pay on a public network to do the transactions, then you are going to pay on the private network as well. Though you are not going to pay with the real ethers on the private network, but you are going to play with dummy ethers. But the way network functions is exactly going to be the same. So with the same environment and parameters of the Ethereum network on the private network. In this framework, users can test new ideas and solutions before adding them to the main Ethereum network. And because it works the same way as the real one, developers are able to correct their mistakes if they have committed any. These testnets also help them to see exactly how the product functions. They're able to record the behavior before it goes live on the main network. Remember that all ethers in the test networks are worth nothing because this is for testing purposes only. We'll be covering 4 main test networks, which are Ropsten, Kowan, Rinkibai, Gorilla. Talking about Ropsten test network, the test network Ropsten is an Ethereum proof of work testnet. One can mine on the network to gain ethers at Ropsten. Ropsten was named after a famous Swedish subway station and made its official debut in 2016. And Ropsten is supported by both Git and Parity clients, thereby enabling developers to build 2 separate project perspectives that they are exploring. In some aspects, Ropsten is pretty much like the mainnet. For example, users can mine ethers on Ropsten exactly as on the mainnet. It also uses a consensus, which is a proof of work method, and its outcomes closely resemble those of the mainnet. These features make the transaction validation more accurate than the other testnets. Other advantage of Robson is that it enables users to mine or claim ethers through the Robson faucet, which is a platform built exclusively for the purpose of giving away free ethers for testing purposes. So those free ethers, they don't carry any value. You can't sell them anywhere, but they are just being given to you for you to test out the network. Then we have Kowan. The Kowan test network, initially introduced by the Parity team, is a proof of authority testnet for Ethereum. Proof of authority, just like any other consensus mechanism, it's a consensus algorithm. One may request it from a faucet to require ethers on Kowan. Named after a subway station in Singapore, Kowan was created and introduced by the Parity team in March 2017. It's very new right now, I would say, Kowan, in terms of development. And this was actually built when the Robson network was attacked. Seeing that Kowan has been created by Team Parity, it is no surprise that it runs on the Parity node. Kowan uses proof of authority as a method of consensus, and only selected nodes are allowed to create new blocks and validate transactions within the form of consensus. You give authority only to a selected network of nodes. Everyone hasn't got the authority. The mainnet does not use proof of authority consensus. Therefore, Kowan is not known to be a precise simulation. The mainnet uses proof of work. Now, the main Ethereum 2.0 uses proof of stake. So why should we test it on proof of authority? Right? So you'll come across many online resources for pushing your test on Kowan, but make sure that you have the valid reasons in mind. Rinkibai. This is nice. The Rinkibai test network for Ethereum is a proof of authority testnet originally launched by Git project, and one may order it from a faucet to obtain ethers on Rinkibai. It's the way Rinkibai has been designed. It is straightforward. It is simple. That's the reason I say it's nice, but it still doesn't use proof of work. Rinkibai was founded by the Ethereum team after another subway station in Sweden. A month after Kowan, it made its debut in April 2017. Like Kowan, Rinkibai uses consensus on the proof of authority, especially the consensus on the click proof of authority. As for Kowan, the protocol makes Rinkibai resistant to spam attacks. All ethers are mined and circulated only on request, and it is as easy to prove your presence as sharing anything on social media and using a link to prove that you are real. Blocks are created with 15 seconds interval. That's the Ethereum framework. The last one is the Gorley test network. This testnet aims to introduce cross-compatibility through the numerous Ethereum clients. The Gorley testnet, named after a local subway station, in keeping with the custom of testnet, has arrived in Ethereum and is now operating in prototype form. It is the first proof of authority network that operates in various languages through several clients, and it seeks to include a standardized and continuously available testnet. The Gorley test network is fairly reliable to ensure continuous connectivity and reliability. There are multiple test networks. There are so many testing frameworks that are available to test out your smart contracts, and whichever actually suits your need, whichever you feel comfortable with, every developer just goes with that one, right? Perfect. Now I will straight away jump to questions in the next couple of minutes. Okay. So, integrated development environment. We have worked with code. We use Visual Studio Code. We use Eclipse. We use so many different IDEs depending on the code that we want to write. In a similar way, we have the IDE to work with Ethereum. A developer's first step on his path to creating an application is to write down the basic logic that is generally written into an IDE. The IDE's ultimate goal and main advantage is that it provides increased competitiveness to developers. The IDEs, the tools in the IDEs, they actually help you figure out the mistakes that you have committed while writing the code. IDEs improve efficiency by reducing startup time and by speeding up the production activities, by keeping developers up to date, and by standardizing the development process. The first IDE that comes to our mind when we especially think about Solidity is Remix, and ETH is another one. So talking about Remix, it gives you dummy accounts with ethers. You can deploy your smart contract, you can inject your Web3, and you can check you can test your code over there. It will give you the errors. You can do a quick compile over there, and you can test your smart contracts on Remix. It is a web-based IDE targeted at Solidity and the Ethereum development environment, previously known as browser Solidity. Talking about the pros, it compiles the code with the current version of the compiler. You can in fact choose the version of the compiler that you want to use. We provide customized systems such as Java virtual machine or an embedded Web3 framework that can be integrated and run smart contracts. And it allows you to import GitHub and Swarm code. It is a bit difficult, but I don't agree to that, because once you have actually started developing and using these environments, it will of course take anyone a couple of days to get accustomed to these environments, but it isn't that difficult. It might be, there is no definition of difficulty, I would say, right? Talking about ETH, which is another browser-based IDE and is quite famous among the developers. ETH is famous for its lightweight features and presentation of the code. Although Remix provides the versatility of checking the code through various networks and ecosystems, ETH is all about presenting the code on display due to its simple embedding capabilities. Pros, that it is easy to embed and upload apps, and cons is that it is not that feature oriented as Remix is. Right? Those are the IDEs. Talking about the local test nodes with the RPC interface. RPC stands for Remote Procedure Call. The way we say we access a website with HTTP or HTTPS, in a similar way, we have RPC, gRPC, gRPCS. This is a protocol which is being developed by Google. It stands for Global remote procedure call, which is gRPC, and RPC stands for remote procedure call. A different way of sending the packets. Test nodes with RPC interface. As you all know that by definition, everything on the blockchain is immutable. Nothing can be changed once stored. Even smart contract upgrades cannot be recorded at the same address and must be distributed as a new instance at a different address. That also means that it is not possible to check smart contracts on the existing blockchain network, as any improvements will be difficult to make until installed on the mainnet. Consequently, testing networks on nodes form an essential part of the Ethereum development tools, since Ethereum developers use local test nodes to test contract integrations. Let's talk about Ganache. Ganache has got a very good UI, and it has got the CLI as well. First on our list of Ethereum developers, the most commonly used test node is Ganache. It is a personal platform for the development of Ethereum, which you can use to install contracts, build apps, and run tests. It is used both as a software program and a command line tool, and Ganache can be downloaded on Windows, iOS, and Linux. By using Ganache, you can have dummy accounts containing ethers. You can have access to their private keys. You can have access to the balances being updated instantly. You see Ganache's internal blockchain log production, including answers and other debugging material. It provides you a blockchain explorer where you can actually see blocks getting mined. You use a simple click to customize advanced mining by setting block times to match the production needs. You can optimize your blockchain the way you are actually planning to implement or push it to the Ethereum mainnet. Examine both blocks and transfers to get a glimpse into what's going on under the hood. Then we have Ethereum, which is now deprecated. So this was a platform written in Python, and that's the reason why it was named Ethereum. This was lighter than Ganache, but it wasn't having those features that we require to build Ethereum decentralized applications. It used a Genesis block to create a new blockchain testnet. It builds a new test state with paths in the Genesis state and uses a private key to send a transaction to the specified address with the provided value and data. But now we don't use this. We only use Ganache. Right? Okay, so I have, let me quickly wrap up this one and then we can straight away jump to questions. I'm sorry, I don't want to leave a piece of knowledge with me. Talking about the command line based tools and the tool suite that we use. Truffle is the most famous Truffle, known by the name Truffle suite for Ethereum development. So it's a command line programming platform that offers a full environment for the creation and testing of applications based on Ethereum. It is used as a testing framework and asset pipeline, which aims to make life easier as an Ethereum developer. The company Consensus is responsible for Truffle development and maintenance. With Truffle, you get a built-in compilation, connection, deployment of smart contracts, automated testing of a contract with Mocha and Chai, which are your frameworks, configurable build pipeline with custom build process support, framework for scriptable deployment and migration. With Truffle, you actually compile the smart contract, you push the smart contract, deploy it to the EVM, and you are able to interact with the smart contract. It has got the basic JavaScript functions. It returns you a promise, or you can, as you await, and you can do that with ease. Network management for deployment of various private and public networks, rebuilding assets instantly during growth, an external script runner which runs scripts in a truffle environment. Talking about Embark, which is another platform for making dApps to build and deploy using serverless HTML5 software. At present, Embark incorporates blockchains, decentralized storage like interplanetary file system, which is a decentralized storage, and open networking channels like Whisper and Orbit into EVM. For deployment, Swarm is supported. With Embark, one can install contracts automatically and make them available in the JavaScript code. It watches for the updates and will automatically redeploy the contracts and the dApp when you change a contract. Test drive contract creation using JavaScript. Keep track of the contracts deployed, just execute when really needed. Save and retrieve data easily via Embark.js on the dApp. Deploy and complete IPFS or Swarm program. And manage dynamic interdependent contract structures with ease. And the last one is DAPL, which was actually scrapped in favor of a new platform named DApp, and was created by the same community of developers. DApp is a basic command line interface designed to build smart contracts, and this recognizes such instances in common use, managing packages, creating source code, unit testing, and easy implementations by the contract. It's actually only Ethereum would have been very similar to Bitcoin, but the introduction of smart contracts got the real power that your applications can be built in a decentralized way, rather than keeping centralized servers, centralized databases where admins have got the full control to go in and edit anything. In short, blockchain is something which is against manipulation. You don't want to trust the people. You want to build applications where you trust the network, you trust the cryptographic algorithms which are running out there. All right. Any questions, thoughts, comments?
Yeah, thank you. Thank you so much, Pranav. So any questions? Just trying to see if there are any questions.
Well, I believe as you are anyways recording the session can be recorded because my screen will also be recorded. And at a later point of time, while they actually want to practice something, they can look at this piece of the recording and replicate. And if you have got any questions, then always you can send us that we are stuck at this point and we need assistance. So that should be okay.
That sounds good. That sounds good. Yes. Yes. Yeah. Anyway, it is going to be recorded and it will be shared with participants, so they can go through it again. And if there are any doubts, always we can share your contact email address so that they can get in touch with you. Yes.
Absolutely, sir.
Sure. Okay. Thank you so much, Pranav. So we'll have lunch maybe, and we will meet at 2:30 again for the second session. Hands-on session. Okay.
Sir, one question is there. Sir, one
question.
There
is one question which has come just now. Sir, can you suggest some research areas to be focused in blockchain?
Okay. So the research areas in blockchain would be that how exactly, I'm not talking about the industry specific search right now. I will answer the industry specific search as well. But right now I'm answering the question related to the technology. If you want to get into blockchain and you want to do more research, then think of that how can you make your blockchains as scalable as the MasterCard or the Visa platforms are? How can you make this technology achieve that speed, that scalability, while keeping the security in hand? So that's one of the major problems that blockchains are facing right now, that scalability is an issue. The moment there was a game named CryptoKitties, which was built on top of Ethereum. That game was developed, but that game completely jammed or hanged the Ethereum network because Ethereum wasn't prepared for that much transaction load. So that is one pain point where almost all the firms around the globe, they are trying to work that how can we make blockchains more scalable and how exactly we can administer these platforms to the masses. Right? So that is going to be one research area inside blockchains. The another research area would be industry specific. Now, if you are looking for use cases, you have understood blockchain. This is what blockchain is. Now, if you are working, for example, you're working for supply chain industry. Now, in the supply chain industry, maybe you can, and that is of your interest, then you can actually figure out, hey, this is one loophole in this industry, and I believe blockchain can come to our rescue if we implement it out there. So try figuring out maximum use cases, and those use cases can actually help you identify that where you can fit in blockchain and you can come up with your innovations. There are multiple use cases. There are multiple problems around the world that you can solve with blockchain.
So,
right?
Excellent. Yeah. So thanks for the.
so next question is software requirement for hands-on session.
Yeah. So I think there is one participant asking for the software requirement for hands-on session. So maybe they also want to do the parallelly in their work in their system. So, so is there any specific software requirement?
Well, you need to have a Linux environment, and that Linux environment on which you will be able to work. Now, if you have a Windows laptop, then you can install a virtual box on top of that, and or if you have a Mac, then you can directly run on the kernel. May I know what's the operating system on which you're trying to work?
Yeah. So, what kind of operating systems you are using, Dr. Dinesh? I'm just waiting for their answers. Let me see. Dr. Dinesh, yeah. In the meanwhile, so
okay.
There is another question, which is, what is blockchain mining game?
So blockchain mining game is all about that you are, I mean, there are multiple games that have been created and in which when you mine or you perform some action and that's a successful one, that's when you are rewarded with some tokens. So basically, blockchain mining means adding new blocks to the blockchain. Now, let's assume that we are 5 people in this forum right now. All of us are running a blockchain node in our laptops. We are in one network and we are all connected to each other. Someone who tries to, and we are doing multiple transactions, 5 of us are playing with each other, right? When you play something, for example, someone hits a goal, we are playing FIFA, you hit a goal, that means you have created a transaction. It needs to be recorded that you have created a goal. So when you have created a goal, that's when you actually mine a block and record that transaction. Whosoever is able to do that, that person is rewarded in the form of some tokens. So that's a blockchain mining game.
Okay, so I think seems to be like most of them are having Windows.
Okay,
But,
so if that's a Windows laptop, then you need to have a virtual box installed on which you will be running Ubuntu, iOS. I don't know if 1 hour would be sufficient to do all of this, but still, let me tell you, we need to install Ganache and we need to install Truffle. What the best I can do is that I do have some softwares installed already on my machine, but I will start from the very basics so that all of those steps can be captured.
Exactly, exactly. Yeah.
So
I think
you
that will
don't
be
have
very
any difficulties while replicating it back again.
yes, 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 exactly.
And if you face any, don't worry about it. We are always there for questions. It's not that you have to ask everything in and if the session terminates, only then your doubts will be resolved. Even after that, you can feel free to send us an email and we'll be happy to resolve.
Definitely, that is great. That is great. Excellent, Pranav. So we will meet again after lunch. So so participants have lunch. We will meet again at 2:30 for the hands-on session in the afternoon. Okay. Thank you, Pranav.